Here are a few more examples of when we get two molecules and we're asked to decide on their relationship. So here's an example. We have sort of this 8-carbon chain, and then we have a 7-carbon chain over here. At first glance it might be completely different. However, if we count total carbons, there's 8 plus a methyl is 9. 7 plus 2 more is also 9. So they have the same number of carbons. They both have substituents, and thus they have the same number of hydrogens as well. So they're not different compounds. We also might observe at first glance that all three stereocenters have been inverted, but that isn't necessarily the case because we've swapped the ethyl and the methyl here, and then we've inverted it. So don't be tricked up by something like that. And most importantly is to observe that the OH is on the 3rd carbon, and over here it's on the 4th carbon. So right there we have constitutional isomers. So there's really nothing else for us to discuss here because we've observed that the chlorine and the OH have swapped carbons that they are attached to. And maybe you observed that right away and came up with constitutional isomers. But it's important, I think, to have similar walkthroughs to start each of these problems, just so we don't skip anything or forget any steps. All right, here's another example. And in this case, we have essentially a single carbon that has 4 different groups around it. So it's just another way of representing chiral carbons. And in this case, we have chlorine, hydrogen, methyl, and ethyl. And when we're examining these, we could certainly assign R and S to both of these structures. And if they're both R, then they're the same. If they're opposite, then of course they're enantiomers. Sometimes it helps just to rearrange the first one to try to match the second one. And thus, if you can make it match, then they're the same. So what's important here to recognize is that the ethyl is on the dash in both of them. And then we have hydrogen, chlorine, and methyl in different locations. And if we look carefully, the hydrogen has gone 1/3 of a rotation clockwise. The chlorine has gone 1/3 of a rotation clockwise. And thus the methyl has gone 1/3 of a rotation clockwise. And so in order to get from the left molecule to the right molecule, all we have to do is go 1/3 of a rotation around this single bond that's right here that connects the ethyl to the chiral carbon. If we do 1/3 of a rotation, we then get to this structure. And so these are identical. Other ways of thinking about this would be to assign R and S here. So chlorine is 1, ethyl is 2, methyl is 3. And if you remember from a previous video, if we can envision ourselves looking down the blue arrow, we would see something like this. And then the hydrogen is in the back. And that would give us chlorine to ethyl to methyl. That would give us R. And we could do the same thing with the right compound. We could envision ourselves looking upwards at it along the blue arrow, and that would get us something that looks like this. And again, chlorine to ethyl to methyl is clockwise, so this is also R. So again, that's just another way of solving this problem. Establishing them both as R means that they are indeed identical.